So a real-life application of these parabolas, we've already seen that anytime you throw an object through the air, it makes a parabola. Here's another application. We've got a cable supporting a suspension bridge, and the shape of the cable is making something. So here I can draw the rest of the bridge. Oh, isn't this pretty? There we can have support cables holding your bridge, just like that. And if you can create an equation that models that cable, well, you can figure out all sorts of things. You could figure out how long do these blue lines need to be if I needed to buy metal in order to build that suspension bridge. And any kind of engineer that would be doing work on stuff like this, they need to put a budget together. They would need to figure out all of these values before they actually build it to see what are the costs involved and what are the materials needed. Because what's not fun is if you have a bridge that looks like this because someone didn't measure correctly. It's not a very good suspension bridge. Might not be safe either, and then someone gets sued, and that's not good either. So here we've got a situation. We need to come up with an equation for this, and when a bridge is out in the middle of a ravine, there's not an x-axis that they glue on there. So we get to choose where we want to put our x-axis, where we want to put our y-axis. And depending on where we put it, we'll get a different equation. So some people, what they really like to do in situations like this is they like to make their x and their y-axis so your vertex is right at 0, 0. That's one way of going about it. You wouldn't have to do that, but a lot of people like to set that up this way. Because then your parabola isn't moved to the left or to the right. Your vertex is right at 0, 0. So when we start with our equation, we're not moving any way to the left or right. We're not moving up or down at all. Our equation just becomes, if you want to write zeros in temporarily, you can, but that's just the same as y equals ax squared. Because our vertex would be at 0, 0. And we've seen in other questions, how do we find that a value? If we know another point on our graph, we can plug that in because that point makes our equation true, and then we'd be able to solve for our a value. All that we're given is this. Can someone tell me another point on the graph somewhere? Okay, how can we use this 140? That 140 is going to help us find which point? And we're going to use the 14. We're going to use that 140 and that 14. So of all these little blue points, throw them down there. That 140 and that 14 could help us find those 2 points. What are those 2 points? Yes. Because you would go 70 to the right if the whole thing was 140 and 14 up. And this one would be 70 to the left and 14 up. So you could use either one of those and say, when y is equal to 14, x is equal to 70, and so our a value, divide both sides by 4,900, is 14 over 4,900. You could change that to a decimal. You could simplify that fraction. You'd have to check, do both of them divide by 7? Yes. So then it becomes 2 over, so here, I'm going to show you something. Simplifying this by hand, Some of you might choose to divide by 2 first because you see that they're both even. That would give you 7 over, what would that be? Right? And then you might be in trouble here. You might have to go to your calculator, divide by 7. That becomes 1 over 350. You could have seen that both of these could divide by 7 first, and then you would get 2 over 700, which is easier to get to 1 over 350 than maybe the other way. Or if you had to go to your calculator to get a decimal, if you did 14 divided by, well, let's get out of here, 14 divided by 4900, and push enter, you get a decimal. Did you know that your calculator has built into it changing a decimal back to a fraction? So under your math button, the very first thing says write as a fraction. It takes that answer, it writes it as a fraction, but when it does, it reduces it to lowest terms. So that is a very helpful thing to do as well. So we get the 1 over 350 that way. So now we figured out our a value, and now we can write our equation. That based on a vertex at 0, 0, we would get this equation. Your textbook has different equations. I think once they move the axis over here, that would give you a different equation. Once they might move the axis over there. But we did it by putting our axes here. If you had a question like this on a test, you would show your work where you put your axes, and then your vertex would appear based on that. So number 11, one that you can do for this, and that is the end of section 4.4.